Our team is called Inside Architects. We're derived from a variety of backgrounds, and we've come together to solve our problem statement. So, how can GenAI be used to accurately predict candidates for C-sections, and what are the ethical and risk considerations for using AI in maternal healthcare decision making? The problem: C-sections are often prescribed despite being medically unnecessary and resulting in adverse effects on both mothers and children. Can GenAI provide a more effective and timely way to identify the right C-section candidates? So key stakeholders include medical professionals, facilities, policymakers/regulatory bodies, and prospective mothers. For our methodology, to conduct initial exploratory data, we used Python and Jupyter Notebook. The primary challenge we encountered was in finding publicly available healthcare data due to strict HIPAA laws, but we were able to locate a limited data set through Kaggle. For our model selection, we used logistic regression model to train because of our small data size and binary classification problem. So yes or no for whether or not someone gets a C-section. For prompt engineering, we consolidated prompts for GenAI tools to ingest data set, train model, and display results. For our GenAI implementation, we fed prepared data sets and prompts to each GenAI tool and conducted comparative analysis of model performance across each tool. Now I'm going to hand it over to Lexi for key findings and insights.
For our key findings, I'm going to start with a comparative analysis across the three systems that we tested for Claude, ChatGPT, and Gemini. For analysis result, Claude and ChatGPT provided very relevant analysis results, well summarized, while Gemini focused more so on explaining how to conduct the analysis with only minor instances of providing relevant analysis pieces. For Python code performance, Claude provided the most sophisticated code where I was easily able to just copy paste the Python script right into Jupyter Notebook for the predictive model development. ChatGPT actually opted to do something separate. It didn't provide any Python code, but actually provided the predictive modeling analysis inside of its system. So as if I ran the Python code inside of Jupyter Notebook itself. And Gemini did provide Python code, but it wasn't a complete and whole code to be able to easily run without bugs or having to provide additional prompts. So it underperformed the code that was provided. One of the prompts was to provide top 3 ways to improve the model system. So each system actually provided pretty similar suggestions and on par and was relevant to it. And as far as ease of use, Claude and ChatGPT has functionality to upload CSV files directly into the system, while Gemini did not. We had to actually copy paste the values directly into Gemini to conduct the analysis. So for use cases, Claude is best for technical individuals who want to modify the Python code. ChatGPT would be best for non-technical individuals who won't be able to run Python code and just allow ChatGPT to do the predictive modeling analysis. And then Gemini is going to be best for only summarizing and explaining the results. I'm going to go ahead and hand it off to Anna to cover the GenAI Playbook and highlights.
I'll guide you through our GenAI's most effective applications across various systems and explore how GenAI tools both were used effectively and ethically. Some of the advantages of GenAI tools were Claude and Gemini provided Python code for transparency and customization, whereas ChatGPT performed analysis internally. However, the interface did have limited capacity. Risk considerations were bias. GenAI systems can exhibit bias based on their training and algorithms. Task understanding models may understand and misinterpret tasks. Code generations, code quality and efficiencies may vary. Edge cases, handling unexpected situations can be challenging. In the best case scenarios, ChatGPT provided ideal for quick insight and prototyping. Claude was suitable for a task requiring transparent and modifiable codes, and Gemini was suitable for performance-focused code generation. Our next steps were recommendations. As you can see, we stayed informed based off our basic understanding of GenAI and how it works and how we could use this to leverage. We also explored various tools, familiarizing ourselves with popular GenAI platforms such as ChatGPT, Claude, and Gemini. We iterated and learned by experimenting different prompts, settings, and configurations to fine-tune results. We stayed informed and collaborative, keeping up to date with the latest developments. And we followed GenAI development and ethical considerations through relevant industries and blogs. In conclusion, as you can see, generative AI is revolutionary in industries, and it's essential to understand its effectiveness. Our insights provided Gen AI to empower women and particularly prospective mothers. By providing accurate and timely predictions, Gen AI can help reduce unnecessary C-sections and improve maternal health outcomes. By bridging the gap and understanding how expected mothers can be enabled with informed decision about their healthcare and their overall well-being. That's it. Do I have a closing statement?